Okay, ANP1 students, this video we're going to continue talking about homeostasis. So in the last video we learned about what the definition is of homeostasis, what's the purpose of it, and then we also talked about the different parts of any homeostatic control mechanism. There was 3 of them: the receptor, the control center, and the effector, and that's their general names. And it goes in that order. Any control system, the receptors are going to have to detect a change first, and then the control center can get information from the receptors and decide what needs to be done. And then the control center has to do that before the effectors can get the signal from the control center to be activated. So in this video, we're going to talk about homeostasis and actually apply this concept to a body parameter that we have a set point for. First, though, I want to talk about an analogy. Usually it's good when you're learning a concept to link it with something that you already know. So it helps you understand the concept a little bit better, and then it'll also usually help you retain it better too. So I think in this case, homeostasis has a pretty good analogy, and there's a lot of other analogies, but this is the one that I like, so I was going to talk about it. So let me pull up this picture, not that picture. I don't think I pulled up the picture yet, so give me a chance here. Yeah, this one. All right, so, and the book talks about this, this as well, so. Okay, so hopefully you can see that picture. Let's see if we can enlarge it. No, maybe not. Okay, so a good analogy of homeostasis is what happens in our homes. So if we have an air conditioning unit and a furnace, which most people do, that keeps our house at a comfortable temperature. So how that works, and everybody's pretty familiar with how this works, and the reason I'm using this example is how this system works in our house is how this system, similar to how these homeostatic control mechanisms or systems work in our human body too. So everybody's familiar with the thermostat that's usually hanging on the wall somewhere in the home, and we manually determine what temperature we are comfortable at. So this one's showing 72. Obviously some people are more comfortable at lower temperatures, some people are more comfortable at higher temperatures. So this says 72. And so what we have is, we're going to relate this to the receptor, the control center, and the effector. So when we're in our home, we have these little, they call them sensors, but we're going to refer to them as receptors. There'll be these little receptors. They're usually located inside this box too. And they are going to be able to detect the temperature of the house, so the environmental temperature that's within the home. And so whenever they detect that temperature, they will send a signal to the control center, which is also located in this box here. They call it the integrator, but I'm going to call it the control center. So they will give that information to the control center. And the control center is the part of the thermostat that knows that we want to keep the temperature in this house at 72. So if the receptor tells the control center that the temperature is 74, then the control center then knows that that's too high, and so it will know that it needs to make a decision and do something to cause that temperature to get back to that set point of 72. So what it will do is it will send a signal through wires to, in this case, if it's getting too high, like going up to 74, it'll send a signal to the air conditioning unit and cause it to turn on. So then the air conditioning unit will blow cool air into the home, and then that 74-degree temperature will drop back to the set point of 72. So we call this air conditioning unit the effector in this case. So, and then you could do this for, in the winter. So if the temperature in the house starts to drop, the receptors are still going to detect that drop. If it goes below 72, then the control center knows, okay, now it's too low, so what I need to do is send a signal to the heater so we can blow some warm air into this house and get that temperature back up to 72. So then the effector in that case would be the furnace. So this is a pretty everybody's pretty familiar with how our heating and cooling system works in the house. So that's a good analogy to go along with homeostasis in the body. Definitely goes along really well with, how our body regulates our temperature at 98.6, but still kind of, same premise or concept as any other parameter in the body, like blood pressure or amount of glucose in the blood. Okay, so now what we're going to do is I'm going to go to the textbook here. And we have these little concept overviews, which I like. They're very nice to overview the main points in the chapters and sections of the chapters. So here's our picture. Now I'm going to real quick go back to our learning objectives here. So we're on 13 here. We're talking about one of the things you need to be able to do is recognize the part of the body that is serving as each of the components. Remember, the three components are receptor, control center, and effector. And so we gave you the example. So for body temperature regulation, or maybe I should put homeostasis here. So that's a term you will see regulation used too, but I'm going to go back to body temperature homeostasis. So this kind of shows what we mean by this learning objective, what we want you to understand when we're talking about a homeostatic control system. So if we're talking about body temperature homeostasis, keeping our body temperature at that set point in that normal range, you should know that the receptors for that, they're everywhere in the body, but we're going to use the skin as an example. So there's nerves in the skin, and they will serve as the receptors. And what they're doing is just detecting the change in the body temperature. So anytime it goes below or above the set point. And then what they'll do is send a signal or an impulse to the hypothalamus of the brain. So there's a part of the brain, kind of in the center of the brain, that's called the hypothalamus. And that's the part of our brain that knows what temperature our body should be, and it controls that. So the hypothalamus of the brain is serving as the control center. And so information it gets from these skin receptors in the skin, it's going to interpret, and then it'll initiate a change by sending a impulse to the appropriate effectors. So it depends on if the body temperature is going too high or if it's dropped too low. It'll determine which effectors are going to be activated to respond. And then the effectors are usually muscles or glands of the body. They serve as the effectors. And so they'll receive that impulse from the brain, hypothalamus of the brain, and then they'll bring about a change in the body temperature. And what they're going to do is when they're working, they're going to get it back up to set point. So let's say the nerves in the skin detect that our body temperature has dropped below the normal range. So that the hypothalamus of the brain will get that information, and then what it needs to do is decide which effectors am I going to activate or send an impulse to so that they can be activated. And so since the body temperature is too low, the hypothalamus of the brain will send a signal to the muscles of the body and stimulate them to contract. So this is skeletal muscles. So it'll tell the skeletal muscles, all those muscles that are along your arms and legs, it'll tell those muscles to contract. And then when muscles contract, you may or may not know this yet, but they produce that whole chemical reaction of them contracting. A byproduct of that is heat. So when we shiver, our body temperature drops and our hypothalamus in the brain send a signal to our skeletal muscles to contract, and we shiver, what we're doing is involuntarily contracting our muscles to produce that byproduct of heat. And that will increase our body temperature. That's one thing that can increase our body temperature. So realize we can do behavioral things too to increase our body temperature, because when we get cold, usually we grab a sweater or a jacket, put a hat on, put socks on, something. So we can do the behavioral things to help, maintain our body temperature. But if we're just talking about what our body homeostatic control system is doing, that it's working on the muscles and the glands to cause an effect to get that body temperature back where it needs to be. All right, so that is our, so I'll say this, whenever we move through A and P1 again, this homeostasis concept will come up again and again. So like, I think the next time we'll talk about, so we're talking about body temperature homeostasis here. So you should understand what's going on in the body, what parts are involved to maintain our body temperature in that normal range or at set point. The next one that we'll talk about is calcium homeostasis when we get to the skeletal system. And what we'll do is we'll talk about how we keep the calcium amount of calcium in our blood at a certain set point or in a normal range. And then you guys will be responsible for knowing what the receptor is in that homeostatic control system, and then what the control center is and what the effector is. So we will, and then we'll move on to another body system, and we'll talk again about something else that's the parameter that needs to. So when we get to heart and blood vessels, we'll talk about how blood pressure homeostasis, how we keep that blood pressure in that range of about 120 over 80. So we'll keep applying this concept through all the chapters in A and P. So it's important to understand that. The last thing I want to say before I end the video is when we move through the chapters, they may, instead of saying homeostasis, they may use the word regulation. So they may say calcium regulation, blood pressure regulation. So they'll use those kind of words interchangeably. So homeostasis and regulation kind of mean the same thing. So just be aware of that as we move through. I'll try to make sure that I stress that we're talking about homeostasis, and this is how we keep this parameter within the normal range or at a certain set point. But just realize the book will kind of go back and forth with those terms. So, all right, so I will see you in the next video.